Hey everyone, this is number 5 from the 2018 FRQ exam. This is part D. The stem of the question is just giving us that function f of x equals e to the x times cosine of x. Part D is introducing a new function. It says g is a differentiable function such that g of pi over 2 is equal to 0. The graph of g prime, the derivative of g, is shown below. This question is asking us to find the value of the limit as x goes to pi over 2 of f of x over g of x, or state that it doesn't exist with a justification. So the first thing that we try when we're evaluating a limit statement is to plug in. And I'm going to actually show you something that is not correct to write. Oh, well, there's something right there that's not correct. We can't have a limit without a function next to it. So I'm going to rewrite the limit statement that they're asking us to evaluate. But when we first learned limits as juniors, the first thing we did was just see if plugging in the number gives us the answer. So I'm going to replace the x value with pi over 2. And as soon as you plug in, remember that the limit statement goes away. So I didn't write limit as x goes to pi over 2 there because I had plugged in already. And f of pi over 2 means that you are going to the f function and plugging it in. So f of pi over 2 is e to the pi over 2 cosine of pi over 2. And g of pi over 2, they gave you, and it's actually 0. And I'm going to keep going just really quickly. E to the pi over 2, we don't have a calculator, so we're going to just leave it. And then cosine of pi over 2. Think about where pi over 2 is on the unit circle. Right here, think about what the coordinates are at that point, 0, 1, and think about which one is the cosine, the x value. So the cosine of pi over 2 is 0, and that gives us 0 over 0. So one thing I learned in my NIMSY trainings is that they do not want you to write this. They don't want to see this. They don't want to see that you're writing something is equal to 0 over 0, because that is not possible for something to equal 0 over 0, which is an indeterminate form. So instead of taking this approach, we have to write it a little bit differently. Now, why did I take the time to write all of that out? Because I think that's kind of what you would naturally do. But then once you realize it's 0 over 0, you want to stop and do things a little bit differently. So I'm going to erase, and I'm going to show you how to write this. But maybe getting that 0 over 0 is making you think of something that we can do in the future. We'll see that in a second. So the way that they want you to write this, in order to avoid writing that something is equal to 0 over 0, you would just look at the numerator on its own and the denominator on its own. So we're just looking at the numerator. The limit as x goes to pi over 2 of f of x. We're going to plug in pi over 2. We're going to the f function, plugging in pi over 2. And then I won't talk through these steps again because we just did them. E to the pi over 2, the cosine at pi over 2 is 0. So it's okay to write it like that because you're saying the numerator of this function is going to be 0. And then you would do the same thing with the bottom. And when you plug in the pi over 2, that was given in the question that pi over 2 is equal to 0. Okay, I find this part very tricky, so I'm going to write because. So they're needing you to write something else here. They gave you this input and output in the question, but what is very tricky about this is, let me write, this is the g function and this is pi over 2. So they're telling you when x is equal to pi over 2, the output is 0. And the question gave you that. I'm going to just show you that again, right? The question tells you when pi over 2 is the x value of the g function, the output is 0. That does not necessarily mean that is also going to be the limit. And I'm going to just draw some random picture here. That would be a scenario where the limit, the two-sided limit at pi over 2 does not exist because the left-hand limit does not equal the right-hand limit at pi over 2. So just because you know an output at pi over 2 is 0, that doesn't necessarily mean that that is going to be the two-sided limit as well. In the picture I just drew, the graph shows a counterexample. What you want is a situation like this, where the output is 0 and the two-sided limit is also 0. But how do we know that we have that? So we're going to go back to this question. It says that g is a differentiable function. So if g is differentiable, then you automatically know that it is what? Continuous. And so in order to have this statement be true, you're trying to figure out what is this two-sided limit, and you plug it in and you know the output there is 0. But the reason you know it's not a situation like this graph I drew, where you have an output of 0, but you don't have a two-sided limit, the reason you know that's not happening is because they told you g was differentiable, which means it's also continuous, right? So you're drawing that without lifting your pen. And that's how you know that the output and the two-sided limit are the same. So this is so tricky, but the AP exam is wanting you to write the reason you know the output is the same as the two-sided limit is because G is differentiable and therefore continuous. Okay, I'm not sure if I would have gotten that point on the test, but let's keep going. So you have tried to evaluate this limit statement and you got a 0 on the top and you got a 0 on the bottom. So does that remind you of something that you are able to use to evaluate that limit statement? And I'm going to grab another copy of this question, just so we can see it, what we're working with. Oopsie. Okay, so then what we're going to do is use L'Hopital's rule. So L'Hopital's rule, you are allowed to apply when you get that indeterminate form of 0 over 0. So we're going to write limit as x goes to pi over 2, f of x over g of x equals, and then I'm going to write L apostrophe H to show I'm applying L'Hopital's rule. I'm going to rewrite the limit statement. X is going to pi over 2. And then what do we do in L'Hopital's rule? We take the derivative of the top and we take the derivative of the bottom. It's not the quotient rule. It's the derivative of the top. The derivative of f is f prime. Derivative of the bottom. Derivative of g is g prime. And then we're going to go from there and try this again. So again, one way to evaluate limit statements is to plug in. So we're going to plug in pi over 2. And we're going to see if this gives us the answer. Again, notice when I plug in the x value, then I'm not writing the limit statement anymore. I just plugged in, so that limit statement goes away. All right, so f prime of pi over 2. I'm going to rewrite the f function, e to the x cosine of x. We have found this derivative in previous examples, so I'm not going to take the time to talk through that one extensively. With the product rule, it was the derivative of the first times the second plus the derivative of the second times the first. We also wrote it as e to the x cosine of x minus e to the x sine of x. So f prime of pi over 2 means that you are taking pi over 2 and plugging it into the derivative, right? So pi over 2 is going into f prime, the derivative, and that is going to look like e to the pi over 2 cosine pi over 2 minus e pi over 2 sine pi over 2. Okay, so pi over 2 has been plugged into the derivative. Then we are asked to figure out g prime of pi over 2. We're going to go back to the question to tell us what they told us, to see what they told us about the g function. So this is the g function, but they are asking me for g prime of pi over 2. So can you see a way to figure out g prime of pi over 2? So they gave you the graph of g prime, and you can go to pi over 2 and look at what the y value is at that point. So g prime of pi over 2 represents going to the g prime graph, looking for pi over 2, and figuring out what the output is at that point, and the answer is 2. So the 2 is going to be in the denominator. So we are almost finished, I promise. The last thing we're going to look at is just what are these values from the unit circle. So again, pi over 2 is up here. We already said the coordinates are 0, 1. So we have e to the pi over 2, cosine at pi over 2 is 0, minus e to the pi over 2, the sine of pi over 2 is 1. And so this is all gone as 0, but we have negative e to the pi over 2 over 2. And that is my answer. What a question. Let's jump to that rubric. So this is only a 3-point question. The first point is being able to figure out that limit as x goes to pi over 2 of g of x equals 0. And you see that statement, because g is differentiable, g is continuous. So yes, they only gave us the output, but we know because of continuity that that's also going to be the two-sided limit. The second point comes from you applying L'Hopital's rule, and that is here. You have to say L'Hopital's rule. I'm going to say one more thing about that in a second, but you can see them rewriting the limit statement, taking the derivative of the top, taking the derivative of the bottom. And then the final point is the answer, which is negative e pi over 2 over 2. Just the very last thing I would just say, this is probably not the greatest or safest thing. So maybe you could, I'm just kind of liking how they wrote by L'Hopital's rule, like they wrote it very clearly as opposed to just that L apostrophe H. I think it's going to be better to be as clear as possible. So I do like that idea of writing by L'Hopital's rule. You can even point just so you're like explaining, I wrote L apostrophe H, but that here's what that means, just so it's very clear that that's what you're using. All right. Great job. That was a really tough one.